Okay, so what I want to talk about in this lesson is the factors that affect the rate of reactions. So factors that um, that impact the rate of a reaction, or so rates of reactions. Now I'm going to look at, there's a few of them. So there's five. Okay, and the first one that I want to focus on is the types of reactants that are used. And in the subsequent lessons, we'll look at the other ones as well. So the types of reactants used. So the types of reactants used. And that makes sense. So for example, um, if you have like different types of reactants will react in different ways. And this is like fundamentally, let's say, um, one of the things that can impact how fast a chemical reaction happens. So what I want to do is I want to look at these examples here. So we have two experiments that we can look at here. So if we have a look, let's go back down here. Let's work that out. So we have two chemical reactions here. So this first reaction, so what we have is, so again, remember on the left hand side, so this and this, these are the reactants. So you have magnesium and it's reacting with hydrochloric acid, which is an acid, and then it's forming these products. So magnesium chloride and hydrogen gas. So this is a gas. So it's basically, so these two components are, these two products or reactants, should I say, are coming together, and what it's doing is it's producing hydrogen gas, and it's also producing magnesium chloride. So what we have here is, so if we take, so we have the pink substance is dilute hydrochloric acid, and then the material that's at the bottom then is this magnesium, which is in solid form. So they react, and you can see these bubbles being produced, and they're bubbles of helium gas being produced. So what's happening is they are, so imagine this is going on in the glass, it's bubbling away. The helium or the hydrogen gas is passing down through here, down through this glass tubing, and it's going in, it's submerged underneath the water. And what's happening is the helium gas is bubbling up through the water, and it's increasing the volume of gas in here. And as a result, what's happening is that volume of gas is pushing down the level of the water. So as more gas is produced, more of the water level is pushed down and dropped down further. And what you can do is you can set up this experiment, start the chemical reaction, so start these two guys reacting with each other, and then observe what happens. And what you'll notice is that this reaction like happens fairly fast. So what happens is the water level starts to drop fairly fast. Now, if we do exactly the same, let's say type of, so we're pretty much using all the same type of material except we change one of the reactants. So in this case, so in this experiment here, we're using magnesium. Okay, whereas in this experiment here, we're using zinc instead. So everything else is the same. The only thing that is different is the zinc that we're using. So you're going to get this chemical reaction happening between the zinc and the hydrochloric acid. But what happens is, so you get the zinc at the bottom, the hydrochloric acid, the pink stuff, and you get this reaction that happens. Hydrogen gas is produced, it goes up down this tube, bubbles up here, and it starts to increase the amount of hydrogen gas that's up here, and it starts to push down the water level. And then you can time that as well. So you can time that. And what you'll notice is that like you can set these two experiments up side by side. But what you'll notice is that this here, this top reaction happens at a faster rate than this bottom reaction. So it's a much faster rate. And what's the difference? The difference is the type of So the types of reagents. So the type of reagents. So in this case, we're using magnesium, and in this case, we're using zinc. So these are two different types of two different atoms, for example, that are reactant. And because of the difference, the change, or the different types of reactants that you can have different rates of reaction. So if we have a look here, so we can take these two experiments and we can plot this graph. So remember, the rate of reaction relates to the change in concentration of the reactants or the products. So what's going to happen is, as the reaction goes on, the amount of magnesium is going to drop, the amount of hydrochloric acid is going to drop, the amount of magnesium chloride will increase, and the amount of this gas, the hydrogen gas that's produced, will increase as well. So the concentration will increase. And what we can do is, so we can measure over time this change in concentration. And we know the change in concentration of the hydrogen gas by the change in the level of the water here. So as the water level drops, more and more gas is filling up this graduated cylinder here, and it's pushing down the level of the water. So we can plot this then. So we can have, so this is our x-axis and this is our y-axis. And what we can see is, over time, we can look at the rate of the reaction. So if we take this red line here, so this relates to this experiment. So we can see that as time passes, the amount of hydrogen that's being produced up here, so the hydrogen is in cubic centimeters, it's rapidly increasing. So you can see over a period of time that it's very rapidly increasing until it gets up here to a level, and then it just stops. And this is like where the reaction, let's say, comes to its final. It's where the reaction has come to an end, and that takes a period of time. So you can see, so from roughly here, so from here to here, so this period of time is how long it takes this reaction to happen. So this first reaction. Whereas if we look at the second reaction, which is the purple line, so that's this chemical reaction that's happening here. So it's a reaction between zinc and dilute hydrochloric acid. You can see that it takes a longer time for it to level off until it gets to this maximum concentration of hydrogen here. So you can say for the second reaction, it starts here and it ends roughly here. So you can see that that's a much longer period of time. So this is reaction 1, and then this is reaction 2. So you can see that the amount of time it takes for reaction 2 to come to an end is much longer than the amount of time it takes for reaction 1 to come to an end. The two experiments are pretty much the same, except the only difference is one of the reactants. So it's the type of reactants that are used. And if we think about this as well, then, so let's say if we go back to, like, why is it that magnesium and zinc, they have different reaction rates? Because essentially they are the same. It's the same type of reaction, only just one of the reagents is different. Now, if we think about what's actually happening, so what we're looking at here is a Bohr structure of magnesium. Now, if we look at magnesium, we can see that if we look at its outer shell, it has 2 electrons in its outer shell. So it has one here and one here. Also, as well, if we look at zinc, zinc has 2 electrons in its outer shell, one here and one here. So these two atoms, what they want to do is they want to lose these electrons. They want to get rid of them, so that they'll have a full outer shell like a full outer shell. Now, if we think about magnesium, for example, remember the protons are the positive charges that are in the middle of the nucleus, and the same with zinc as well. So what's going to happen, let's say, in this chemical reaction, you're going to have, let's say, a magnesium atom, like so, and it will have the 2 electrons on the outer shell, like so. When you take hydrochloric acid, so when you put HCl into water, what's going to happen is so imagine you have HCl, so it's going to split up into 2 hydrogen ions, and then you're going to have 2 chlorine ions, like so, because you have 2 of them here. And remember, chlorine has 1, 2, 3, 4, 5, 6, 7 electrons in its outer shell. has 7 electrons in its outer shell. Now, what's going to happen is the magnesium here, what it wants to do is it wants to get rid of these 2 electrons. And what it'll do is it'll give, so it will give its 2 electrons to these 2 chlorine atoms. So what's going to happen then is, so imagine these are the electrons, chlorine is going to gain these 2 electrons. And what will happen then is you will get magnesium that will have, because it's lost 2 negative charges, it's going to have 2 positive charges. It's going to create an ion that has a 2 plus positive charge, because it's the balance of protons and electrons is not the same anymore. So now it has 2 more protons. It has 2 protons that doesn't have 2 electrons to counterbalance it in its outer shell. So it becomes an ion. So it becomes positively charged. So each of these guys here, they are going to gain an extra electron. So they're going to become negatively charged ions, like so. And then what's going to happen is these guys will be attracted. So this chlorine atom will be attracted to this, and this chlorine atom will be attracted to magnesium as well. And then what will happen is this will form magnesium. This is our magnesium chloride. So we'll get this compound formed. Now, if we think about the 2 heliums, what they want is they want 2 electrons in their outer shell. So what the best thing for them to do, so this here is what's known as an ionic bond. Okay, and this is just revision on what we've done. So that's how, let's say, the magnesium will form this. That's how this turns into this. Now, if we think about the hydrogen, then what are the options for the hydrogen? So hydrogen wants to have 2 electrons in its outer shell. So the best thing to do is for these 2 here, they can actually buddy up. So they will buddy up and they'll share the 2 electrons with each other. So they'll share it like this. And this here is what's known as a covalent bond. So it's a covalent bond. So then what you're going to get is you're going to get this. So you're going to get plus H2. So you're going to have 2 hydrogen atoms connected together, and this is your hydrogen gas that's produced here. And this is going to be in gas form. Now this is, let's say, like, this is just what happens. So basically, essentially, a chemical reaction is reactants changing into products. And really, like, what drives that reaction are like the positively charged protons in the nucleus, and then you have the negatively charged electrons that are floating around outside the nucleus. And this is what, like, so this essentially is what drives all chemical reactions, is the movement of these electrons between reactants and products. So you can see here, so for example, the magnesium loses electrons to the chlorine, and then what happens is these ions come together. So these, like a positive and a negative charge, attract each other. And then the same here as well. So we have, like, this, instead of like the movement of electrons, we have the sharing of electrons. So you have bonds being formed and bonds being broken, and essentially that is what chemical reactions are, and that's what underlies chemical reactions occurring. Now, if we think about then what's happening is exactly the same thing is going to happen with zinc. So I could just as easily take this magnesium and replace it with zinc, for example. It's exactly the same thing. It has 2 electrons in the outer shell. Now the difference is, if we think about, the difference is, look at the amount of electrons between, so look at the density of the electrons between the core of a zinc atom and the outside of the atom. And the same then as well with magnesium. So what's going to happen is, because there's this like vast difference, so there's much more electrons around the zinc core, the ions that are formed, so these zinc ions are not going to be as strong as the magnesium ions, because the magnesium ions, the positive charges from the inside of the core, are not, if you like, dulled down by so many electrons on the outside. Whereas if you think with zinc, for example, zinc has loads of electrons between the positive charge, which is on the inside, and from the protons, and this negative charge here as well. So essentially what's going to happen is you're going to get zinc. So let's say this magnesium ion So if you have a magnesium ion and then you have a zinc 2+ ion as well, this magnesium ion is going to be much stronger because there's not as many electrons between the positively charged protons that are in the middle and the outside. So essentially what will happen is this zinc or this magnesium atom is going to be giving out a positive charge, but it's going to be much stronger, so it is, than the zinc, because the zinc positive charge is being dulled down by the amount of electrons that are surrounding it. So as a result, this is going to have a much stronger pulling force, and it's going to attract these chlorine ions much more quickly to it. As opposed to zinc, it's going to take a little bit longer. It doesn't have as strong a pulling force on it. So as a result of that, what's happening is this reaction here is going to be much faster than this reaction here. And that's because of it's basically because of the arrangement of the electrons, or the electron configuration in the two reactants, the difference between the two that we're using as well. So that's just one of the reasons why different that's one factor that affects the rate of a chemical reaction, is the reagents that the reactants that are used, so the stuff that we start off with. Okay, so hopefully that makes sense, and thank you for listening.